Alright, so this one says devise an algorithm to select the radii for points uniformly distributed within a sphere of unit radius. This is a generalization of sampling points in a circle discussed in class. Show that the efficiency, so the number of random numbers that you generate, yields a value that's inside the circle, is given by pi over 6. So, if you have a sphere that has radius r, and it is in a cube, I'm just going to draw this is a two-dimensional version, with side length 2r. And it says so you'll pick 3 random numbers. Call it row I, row J, row K. And you can say that this is the origin. And you have a axis here. So you can say that xi is going to be equal to r1 minus 2 row I, and y sub I and z sub I are the same, except it's row J and row K. And you can do this a couple different ways, but you have to make sure that it works whichever way that you're doing. What this says is that you're finding these values from 0 to 1. You can generate random numbers that go from 0 to 2, in which case it would be different. So at a minimum of 0, your xi is going to be equal to r times 1. So this will go away. So that means that your point in the x direction will be here. As you increase, if you increase row, you're going to move this way, and here is where row would equal half. So 2 times half is 1, 1 minus 1, 0. All the way down to where row equals 1, where 1 minus 2 is negative 1, and you get to the point negative r. So this would be x sub I equals negative r. So this is probably too in depth in what you guys need to go.
Can we just generate a number from -1 to 1?
Yeah. That probably would be the easiest way to do it. But this is, if you're going to actually make, I guess just make the algorithm, so this could be your algorithm. You can make a number from 0 to -1. That'd be easy. But what we're going to get is that the number of points that are inside the sphere versus the ones that are outside the sphere, we have to find out how many are going to get in there. And it's going to, if you take an infinite number of random numbers, it's going to be exactly equal to the volume of the cube, the volume of the sphere over the volume of the cube. It's going to be the number of points in sphere over the number of points total, which number of points total is the, they have to end up somewhere in the cube. So, yeah?
No, I would agree with you.
Oh, that's me. So, the volume of the sphere is 4 thirds pi times big R cubed over 2R cubed, which is equal to 4 thirds pi R cubed over 2 times 2 times 2 is 8 R cubed. R, those go away, this becomes a 2, and you end up with pi over 6. So, showing that it's equal to pi over 6 is really easy. You just say that if you take an infinite number of points, is the ratio is going to be exactly equal to the volume ratio, which makes sense. But your algorithm could be different. Your algorithm could be the same as this or different. I don't care if it is just to work. Anybody have any questions on this?